Chapter 1 Electrostatics Chapter 1.1 Electric Charges and Electric Fields. Figure 1.1 shows some common phenomena of static electricity. The attractions in these cases are due to the action of electric charges. In fact, electrostatic forces can be attractive or repulsive sometimes. Part 1. Two kinds of charge. When some insulators are ruptured, they become charged. For example, when acetate and polythene strips are ruptured with a woolen cloth, they become positively charged and negatively charged, respectively.
Rub two acetate strips with a cloth. Bring them together and observe what happens. Rub two polythene strips with a cloth. Bring them together and observe what happens. Repeat using a rubbed acetate strip and a rubbed polythene strip. Hold a rubbed acetate strip close to an uncharged acetate strip and an uncharged polythene strip in turn. Observe the result.
In the video, we can see positively charged acetate strips attracts polythene strips, and we say unlike charges attract. While in the first two diagrams, two similarly charged strips repel each other, and we say like charges repel. So we may conclude like charges repel, unlike charges attract. The force between electric charges is called electrostatic force. Electrostatic force obeys inverse square law, which means the force is inversely proportional to the square of separation, just like gravitational force. Let me give you a gentle reminder before we move on. We may say two objects are similarly charged, or we say they carry like charges, which means they carry charges of the same sign, but may not be the same in magnitude. But when we say two objects carry the same charge, then their static charges are the same in magnitude and sign. Part 2. Where do charges come from? The following may be too easy for chemistry students, but still necessary for students who study no other science subject. There's conservation of energy as well as conservation of mass. Matters cannot be created, and similarly, electric charges cannot be created. When acetate strips, polythene strips, and woolen cloth are ruptured, their particles come into very close contact. It turns out that polythene particles are very powerful to pull electrons from woolen cloth, and so the polythene molecules gain extra electrons, while woolen cloth molecules lose some. Polythene strips becomes negatively charged, while woolen cloth becomes positively charged. Similarly, excitated particles are very weak to hold their own electrons, while particles of woolen cloth may pull off electrons from the excitated molecules and gain extra electrons. So excitated strips becomes positively charged and woolen cloth becomes negatively charged. Such process of charging is called charging by friction. So rubbing materials together does not create charges, but only transfer of charges. Part 3. Unit of charge. The amount of charge is measured in coulomb. Say, you may know an electron carries 1.6 times 10 to the power negative 19 coulomb of charge. So a coulomb is a very small unit. 1 over 1.6 times 10 to the power 19 electrons amounts to just 1 coulomb of negative charge. An excited strip typically loses 10 to the power negative 9 coulomb of electrons when it is charged by friction. Now try checkpoint 1.